like a lot of people say, I'm in 20 years in data science, and I don't even know what that means really, but we say it's measured not by number of years, but by number of unique notebooks that they wrote, the number of data sets you touched and different types of models you touched, and different scenarios and different types of dirty data you touched. It's a really large factor for how experienced I think you are.
Hello everyone, welcome to the Data Scientist Show. Today we have Philip Tannor. Philip is the co-founder and CEO of Deepchecks, a Python package to run checks for machine learning models. Previously, he was the head of data science group at Israel Defense Force. He has a master's degree from Tel Aviv University in engineering. His thesis was about a new algorithm that combines neural networks with gradient boosting decision trees. Today, we'll talk about his career journey, how he built his data science muscle memory, the algorithm he worked on, and how to check ML models. If you like the show, give us a 5-star review, subscribe to the channel, and send me a LinkedIn message if you want to sponsor the podcast or share your feedback. I'd love to hear from you. Welcome to the show, Philip.
Thank you so much, and it's great to be here.
So how did you get into machine learning?
So for me, it's a love story, basically. So I'll say I started off with my bachelor's in like physics with a minor in math, touching kind of into computer science, but I didn't know what I loved right at the beginning. So I started off doing operations research, which was like kind of deep into probability and statistics, but with like writing a lot of like documents, kind of reviewing different solutions and so forth. And to kind of make sure I was staying analytical or, deeper into code and so forth, I was doing a master's in electrical engineering. So two things happened in parallel. One thing is while I was doing this degree, when you do it in electrical engineering, you have like a ton of possibilities. You can take like a course about anything you want, from like learning about radars to deep math kind of courses to anything. So I just discovered that like algorithms is interesting. And then at the same time, in my operations research role, which was in the Israeli Defense Forces, I was part of a program called the Talpiot program in the Israeli Defense Forces. So they came to present a project to me, which was like trying to do something like really, really cool using machine learning, which I've never heard of. So that like knocked me off my chair. I said, this is going to be everywhere and I have to do this. And what's really cool about like the studies I was doing is it was flexible enough that once I discovered this was like a passion of mine, then I could like spend like every minute I had diving into machine learning and data science.
Cool. Thanks for sharing that.
So you worked in the military. Compared to the university, what was the research environment look like? I don't have experience in the military, but my assumption is if my rank is higher than you follow my order. But in data science project, there's a lot of uncertainty and discussion. People might disagree with each other. How is the peer review process look like?
So this is like a really, really interesting point because I was in a really special group called MMM. Mm-hmm. It was part of a large computer unit in the Israeli Defense Forces. And I think you're kind of right, like around us, like everything else, it was a really significant military culture with clear hierarchy and so forth. And somehow there was this little bubble that everyone was protecting. It was led by, who was then my commander, an amazing person named Sefi Cohen. And I think we grew the place a lot, kind of, both together, and he did a lot of work before me and after me. But then also, I think the executive, like the high up commanders in this unit, they also realized like the importance of having like a clear kind of research environment. Somehow there was like a completely different culture within this group. So I actually remember a very specific phase where there was like a new kind of soldier, like a brilliant soldier, top grade from university, was going to join there. Like 2 days later, he was going to correct me about like, things I made mistakes about and so forth. But then he came in like in the first day, like after boot camp, and I was like the only person sitting there. My rank was a captain. And then he like came into the room and he was like, hi. And it was like, just like standing there, like, I think like waiting me to give him like an order. Like, oh, wait, I have to. Anyway, it was like no formality, very friendly, kind of joking, tried to find the environments where we could just kind of, do what we needed to. We'd also have like civilian computers with like, really strong CPUs and kind of, RAM specs and so forth kind of working. So this is just in general in terms of the setting, which is like, let's call it the not negative side, wasn't hierarchical and closed and so forth. But I think there was a positive side. It was like maybe like the best research culture I've ever seen. I was in not like one university. I got a chance to like be part of many different universities, and also to see it in different places. So we would have like every week, we would have like every Thursday, we'd have like each person would like read a paper, dive into the paper, show the paper. People would like criticize it, show how he didn't understand it right, how maybe the person who wrote the paper is right. Someone would like in the background be trying to run the code at the same time, and it was crazy. It was so you would learn so much from that, and the pace was so high that afterwards, when there'd be like a colloquium or something like that in university I'd go to, it just feels like molasses. It's like, why aren't they as tall, as beautiful, or whatever kind of culture type thing. So that was really an amazing experience. And just about peer reviewing, I think we had like a really interesting process there. And I feel like I mentioned earlier that I kind of started in operations research, where operations research, it's really about the initial assumptions and about not like making any large mistakes that like change the whole assumptions of the work you're doing. And then like the recommendations, you wouldn't be like, buy 200 units of this instead of 20 because you assumed like some number is 0.1 and not 0.4 like at the beginning of the work. So there's a ton of work about like being critical. And in operations research, there was a process where when you finish your work, then you present it to the team, and you get like, you like go home crying at that. Like everyone tells you like everything that you could possibly have done wrong about it. And when you give in your report, everything, you get it back red and you fix it. So in like a less extreme manner, but pretty similar, I tried to bring this kind of peer review process, machine learning research we were doing. I think I learned a lot about machine learning from this. First of all, just trying to give comments and think critically about what could have been assumed that isn't true about other people's work, but also about either my own work or at some point work I was supervising. When there's like this one day, the Wednesday of February 19th, you have to present to the whole team, and it's a critical crowd. So you're going to do the work is going to be a lot more thorough in advance. And then when you come there, then you kind of prepare towards that day. And then you'll get, some interesting comments, some important comments. You'll get some connections to like other data sets you didn't think of, other models you didn't think of, and just other ways to kind of approach the problem. And this process where kind of assumes that it's not end-to-end ownership. Like there's one person that's leading the research, but really like your entire team cares about the results about the research, and then anyone can contribute, and you'll end up going with the best ideas and so forth. But this kind of process, I think, is really, really interesting. And it also led to an interesting blog post I wrote once about like research review in data science. And then like I tried to list like all the specific things you might want to look at and kind of dive into in a process like that, which does not always have to be like in front of a whole team, but sometimes it can be in front of like just like a specific advisor, maybe a more senior or kind of parallel other associate.
Yeah. That's a very interesting process. And similarly, I think during my experiences at Amazon, in certain teams will do presentations and people give you feedback. And what I learned is not everyone has the insights of your model, your data. So some people, they might be senior than you. They might propose you to try this and that, but it might not be relevant. Or sometimes you have a timeline. You might not have time to try everything. And what you're trying to optimize is within a certain time frame. You can always add a new feature to your product. So when it comes to your process, how do you decide whose feedback to take?
Okay, so I think that's a really valid and interesting point. So first of all, I mentioned some projects, which I usually find is the more interesting projects, are like a go no go project. So if you go to like churn, LTV, object detection, and like sterile environment, type projects, you kind of know it's going to work in advance. And then like there is some sort of research to like optimize and get like a better number at the end, but it's not like that hardcore. Sometimes it could be like, redoing algorithms for a certain radar. Let's like take this and let's see if the few samples we have can be enough to like teach it. And then you don't know if it's going to work. And in the past, some of the use cases I just mentioned would work. And then I think there are two interesting points. One of them is like sometimes there's the issue of is like the information here not rich enough to get something to work? Or am I just not good enough? Like, did what not me personally, but are the process I did not good enough yet? And for that, I think it's really important to have other kind of minds within it. Then I think even for a case where I'm just like trying to get better accuracy. So I'm doing, I don't know, face recognition and for a certain use case. And given the data set or the population or the lighting or the resolution, whatever, I'm getting to 0.94 with some metric, and maybe I could get to 0.96. I think you're right that it's that sometimes it's like, okay, I'm supposed to finish in 2 weeks, so why should I present it now to people who are going to give me suggestions that take 10 weeks? So I think here there's a really important like internal process that has to be done, which is when you present. My intuition is you have this review early, and then this question if you're so let's call it the first kind of viable model where you have some sort of intuition about what the end is going to look like. Even if like your AUC is at 0.7, it's going to get to like 0.84 later on. So it's already enough to get feedback from intelligent people. You should do it, because if you meet them later on, you won't be able to address their feedback, right, which is completely fine if like you just need their formal approval. But if like you really perceive it, I mean, as a researcher, it's harder. But when you're managing a research group, I think this is the type of culture you want, that the person leading the research, he's not like, it's not like his private property. He's leading and he's the main figure, or he or she, but he's doing what's best for their organization. And this is like, he's committed to the feedback. And sometimes feedback just can't be addressed, and sometimes you'll decide, but it's their decision in some manners, but in other manners it's not really. Here you need like some teeth kind of within the management or the advisory or mentorship type process, where it's not okay for them to say, okay, I'm just going to try random forest because I just don't feel like trying XGBoost or that type of thing.
Got it. Yeah, so it depends on different scenario, and also how critical the project is. And also, I guess it depends on their current performance, how close or further away from the goal. Yeah, that makes sense.
Right, but wait, just one more thing I want to say about that. I think when you when you decide, let's do a machine learning project, and then you kind of set what's the data, what's this, what's that. I think at that phase, you already want to send an invite to everyone on the team for the date when the review is. You might have to move it, but you already want to know, like, there might be even more than one review depending on the complexity, depending on the phases. And then you get to the point where it's done early, because you're assuming you'll have like enough information by then to present. And this like presentation is like as important almost as the final release.
Yeah. And also having those presentations, even if you're not completely ready, forces you to make some progress. And also it's also helpful for you to get feedback early so you can adjust your model. And I think it's funny you mentioned you get like a report. Sometimes it can be very brutal, and it could be stressful sometimes. Although people are trying to be objective, they try to help you improve the model. So how did you handle the criticism? How do you kind of separate the criticism hurting your confidence, hurting your ego? How do you kind of move forward with that?
That's a complex question, and I'm sure that different people would reply otherwise. I think hurting ego in a positive way is a positive thing. So when there's like a personal insults about intelligence or whatever, I don't see any place for them. But if from this, your ego as a researcher is, okay, you know what? There's something I didn't think of. I should not have split the data like that. How did I do, I don't know, cross-validation on time series without like looking at the different ways I could have split it? How did I mix the geographies in this way where the train and test have some sort of leakage? Like, there are a lot of different things that can come up. And I think that type of modesty is important for a researcher. It's not fun, but it makes you a better researcher. And that's like part about, I think about like good work ethic is it's not all about having the best time at every phase. Part of it is, and you wouldn't want to choose something which isn't fun for you. But I think for the organization, you really want like a culture of excellence. And part of the culture of excellence is giving the criticism. Part of it is accepting the criticism. And as like, team leaders or managers, I think it's a responsibility to make sure that it's not like optional, and it's not, you don't say, okay, those that don't know how to accept criticism very well, then for them, we won't tell them that there's a problem in their model, and we'll just, let them have like a lower accuracy. You have to build a culture where it's mandatory, I think.
Yeah. I know in the military, you probably won't be able to share all the project, but you mentioned you published paper. Can you just give a sense of what kind of projects you were working on, or like your team is working on, what type of problem you're solving using machine learning?
So about like the specific projects, I don't think I can elaborate that much. I could just say, I think what was really special about this group is we did tabular data and time series and text in different languages and computer vision, all by just a group of researchers. And you might think, how could they have a time? By, having, at some point we had 3, at some point it grew to 10, 15, now they're a lot larger. But I think what really happened there was really something magical where we did not own the whole process. Today, I think there's like there's a process that's growing more and more popular about saying like full stack data scientists, where like from the first time you hear about the project, you characterize it, you do everything until like owning it in production and monitoring and everything. So, there are advantages and disadvantages, I think, to that. But for whatever the case, we got to be spoiled. We would like work with developers from other areas from the organization and so forth. And we would get to the point where they were working on like a really interesting project, and it was really cool and we loved it. And then we looked at the data and we said, this is really interesting, but I think that, we need another 2 months of data. So let's meet in 2 months. And we'd work on another project in the meantime. And that's amazing. It got to the point where, I could work on, I don't know, like over the course of, 2 years to work on like 15 different projects and only be in the most interesting parts. I think it got to the point where our group was like highly specialized at kind of the tougher parts. Let's call it the toughs that are a bit more similar to Kaggle. And then it also matured a lot of these organizations we were collaborating with, because we didn't like take over all the modeling work. Like a lot of organizations learned how to do a lot of the processes on their own and so forth. And then like we were only there for some specific parts. So they could own it and do like if they had a new version similar with some changes in the future, then they could do it on their own. So anyway, I think some of the interesting things I mentioned, like the more kind of precise types of data, but in the military, a lot of times you have like interesting data that comes from sensors that aren't like the well-known types of sensors. And there you really have to like be very original. And we would apply techniques that we learned like while doing NLP or computer vision. And some things would just be from like, some of us happen to know physics or electrical engineering and then like learning what to apply on. But I think what was really cool was that I wouldn't be working on like a project for more than like a couple of months of this style. And then even while I was working on a project like that, I'd be giving peer reviews about NLP or cybersecurity or this and that all the time in these types of meetings, like I kind of mentioned earlier. So amazing experience and so forth.
Yeah, I do want to talk about your thesis a little later, but you mentioned you were on the team that builds some model that has more specialization, and then if other teams use your model, they can make their own changes. But for example, when you first deliver your model to a partner team, do you help them with some testing, deployment? How does it work?
So I can tell you what my mature self would say like today. I've already been at, Deepchecks for a couple of years, but basically when we were there, the answer is not really. We would work on like mainly like the scientific phase and so forth. And then we would be there like as an advisor for like the next part. So it would be like, see, we're trying to put it into production. Here's what we thought of for monitoring. What do you think? And then we'd be like coming into the room like, yeah, that sounds interesting. Cool. Let me know how it goes, like type thing. And, today people call it like throwing the model over the fence. So we were totally there. I think today there's a balance. I'm not a huge believer in the end-to-end data scientist. I can see the magic in it. And in some cases, like recommender systems or, anything that's like really online and like a lot of A/B testing, I can see why you need it. But in general, I'm not like a huge fan of that approach. But I still think that data scientists should own at least like the testing aspects and so forth, and then be part of configuring, monitoring, and things like that for later on. But no, we didn't like own it as much as today I think you should have done when I was there.
Yeah, I think it makes sense if you are on a research team or in some organization, like the first organization I was on in Amazon, we are more like consultant, provide advice, and sometimes you provide a solution and other teams can customize. And if you on a team that works on a specific product, like you mentioned, a recommendation system. I don't think data scientist has to do everything, but after you deliver the model, you can put on the hats of a product manager or program managers to see how engineers deploy your model, whether it works. Because sometimes the whole workflow, if there's not one person pushing it, sometimes it just fall apart. And it's also useful to even work with user researchers or product managers to understand whether people one using your feature or what's their feedback, or looking at the A/B test. So I think in those type of product teams, it makes sense for data scientists to be end to end, to own the entire process, meaning you focus on your modeling, but you collaborate with other people. But yeah, I don't think data scientists has to do everything. We should do the things we are good at, and that's why we are hired for. So, and you also mentioned you trained a lot of data scientists. Can you share how did you train the data scientists? How do you help them ramp up with data science skills, building their muscle memory?
So there was someone else that was like, in charge of building like a large training program for this research group I was part of. The idea was we had access to like a large group of like talented people that came from either Talpio, the program I was part of, or others, without any like real formal background in machine learning. So they didn't have background like, or that much background programming, or programming at least in Python. So there were all sorts of programs that existed kind of online at the time, including I think what was most popular at the time was Andrew's Coursera course. And then there were once in a while you could find some sort of notebook for like learning how to do pandas or things like that kind of online. Then there was Data Camp. But what we saw is that if we like just throw our new recruits into these materials and then we'll like test them after like 2 months, then they won't know that much, which was really disappointing. It was really disappointing to see that. And like even like I'm taking like Andrew's course, I think Andrew does like an amazing job explaining, and with a specific explanation you want to go and see like what's the best way to phrase it. I think looking at that looks good. The combination with that with MATLAB or Fortran, and in general about like most of the code kind of being written and then you just like add some lines. For whatever reason, when people would like, if I would like test people like right after the course, I'd feel that they didn't learn that much in 3 or 4 weeks. I know so many people got into machine learning because of this, so it's hard for me to be like kind of productive, but it's hard for me like not to be like, really positive about this because, so forth. But for our people, where we needed them to ramp up really quickly and then like own projects on their own really quickly, we were like, okay, we need something of our own. So we really like listed all these different, in like a large Excel, all these different skills we need. And we would basically build like a notebook for everything, which was really challenging. We had like some really kind of really cool gimmicks. Like we do like just to make sure they're good enough with, computers. So we'd have things that we'd give them like hints that are like written with like different types of ASCII codes, or like all shifted like one to the next letter. And then, if you run like a cell you're not supposed to because it gives out the answer, but you didn't do some sort of process yet, then it like kills a notebook and kicks you out of the notebook, and like a lot of things like that. And I think it was really amazing. And we ended up like, it was like a natural evolution. And we can't, like the people that were being trained would like rank the notebooks that they liked. And from like a popular one was like starting off by like building recommendations for Netflix based on, the Netflix prize data. But then like using a neural network, which, wasn't that common that everyone would use it like then, and then take the embeddings, and from the embeddings, kind of visualize, different clusters of movies. So those are like the types of things we'd have in the notebook, and then they learn a lot of things all at once. But then when you kind of go back to the end, and they'd say what they like more, what they like less, and we'd like kill the bad notebooks and put in like new ones and make sure the subjects are all like everything's pretty much covered. So at the end, people would like finish these drills, and then we'd feel that they're already like pretty skilled. It's almost like they're mid-level. They're not like senior, but they're not they wouldn't feel that junior to us. Like they've touched a lot of data sets, and this led us to like some sort of realization, which I it's like a quote that I like to bring until today, but it came up from this training and seeing all these people. We like to say that seniority or experience in data science isn't measured by number of years of experience. People say, I'm in 20 years in data science, and I don't even know what that means really, but we say it's measured not by number of years, but by number of unique notebooks that they wrote, the number of data sets you touched and different types of models you touched, and different scenarios and different types of dirty data you touched. It's a really large factor for how experienced I think you are. So that brought us to write like one of the first drills we wrote is something that we call muscle memory. It's like a very simple idea, but no one's really did it. We took like dozens and dozens of data sets, and then we just have like a clear thing. You have to do X and Y and Z to the data set, get to the point where you have a running model. And at the end, they want you to compare the results of all these different models for each one of the data sets and, run like, 5 models on it, compare it. And it just gets to the point where you're doing like the same type of thing again and again and again and again. And like while you're doing it, you just feel like this is dumb. Like, I'm not learning a lot and so forth. And by the way, all of them were small data sets, or if it's a large data set, we only take like the top because, you don't learn anything by waiting around and like watching the loading of the notebook or symbol at the side of the notebook while something's running. So you get to the point where you ran it on, I don't know, these 50 data sets and, classification, regression, and different types of data sets. And for each one of them, build the model, get the results, evaluate them, split, do this and this and that k-fold. And then, it's really cool. Then in all the next drills, which are the more advanced stuff and like diving into the embedding layers or whatever, more sophisticated things, the simple stuff that they feel like they've done it 100 times, even though they've like only been a data scientist for 2 weeks. So that's like, I think my one like favorite drill I like, and it would take them a lot of time, and we wouldn't let anyone stop in the middle also.
Mm-hmm. So for data scientists who want to improve their skills, how can they kind of use the similar process for their own learning progress?
So if I would do that now, like even after being in the space for many years, I'd still learn a ton. I would depending on how much time you have, I would probably do like the exact same program for myself today. And I wouldn't remember, I'd learn some new things. I'd maybe do some things better today. That's one thing. If you don't have enough time, then I would look into, a combination of which of these things do I not know well enough together with which ones may be important for me or my team in the next year.
And then just practice, do a few practice using Kaggle dataset to learn it.
So I mean, it depends. Like muscle memory, I think the muscle memory is not as important for like experienced data scientists, but like these drills, which are like kind of per topic, I think can teach you a lot. And then if per topic there's like a challenge, a well-written, challenging drill that kind of like we actually in Deepchecks, we actually wrote like a couple of drills for learning how to test machine learning models. But even if I wouldn't go into like that one, I'd go to something of the sort of saying, okay, let's say you're trying to learn how to write a custom loss function for a neural network using PyTorch. So there's a drill for that. And then you should never have too much pride to say I'm going down and doing the same thing that we might give someone in a training program. It's very not like university courses where like there's no reason for me now to go back. Maybe if I was a mathematician, but there's no reason for me to like go like now to like my first calculus course and like redo the drills. Here, I think it teaches a lot to go back and redo things. And if you're a better data scientist, you'll do it faster. Your code might be cleaner, but you're not going to remember, even if you just take like a pandas drill or a NumPy drill, you're not going to like be, oh, this is all easy. I remember everything. If these exercises are good.
Yeah.
And by the way, I just want to mention for the team, we would have back then something which we would call like a quarterly boot camp. So what does a boot camp mean? It would mean, it started off by saying, okay, we all want to compete together in like a competition, either a local hackathon or like take a Kaggle, you're not going to be like first place at a Kaggle competition in like 2 days, but we take like 2-3 days where everyone drops their regular projects and all works together on something like that. Like a 2-day project where you'd be like, okay, we're all working together as a team on this challenge. And we learned a lot from it. It helped a lot for the team. And there, obviously, the seniors were more dominant than the juniors, but you really get to work together. Whereas in regular like data science collaboration, it feels like you're working together. You're not really working together. Like it's really solo work where you might get like some advice, or someone might like run like 3 or 4 cells. So here you're actually, it's like telling someone else, dude, where are the, I'm waiting for your engineered features. I can't run the next part. Wait, let me see. Why do you do it that way? And then like they come in and they actually care about you working both quickly and to deliver the results like in the specific part of the pipeline. But what does happen in these challenges is people usually don't end up like doing end to end. Like one person's in charge of, creating the features, while others like experiment, others assembling, and so forth.
Mm-hmm. Let's go back to the thesis in grad school. So can you tell us more about the algorithm you proposed, and how did you improve on top of XGBoost?
It really feels like a baby to me. I think it's a baby both to me and to Leo Wolkach, that was my advisor at the time. And originally, the idea was actually, he had like the idea of what it might feel like for years in his mind. And I was happy enough to be like a promising enough student for him to to let me be the person kind of working on it and then expanding it. So first of all, I wrote a blog post about it. If anyone like listening to this wants to see, so it's called something like OgBoost, like XGBoost with a few twists. I'll mention again why twists. So the idea is, if you take something like gradient boosting, which XGBoost is based on, the idea is like you start off by a model like a decision tree that kind of learns what a decision tree would learn, which is basically it's trying to optimize the loss function, given the the predictions it has and given like ground truth labels on the training data set. So you get to the point where you build a tree using whichever method, and then what you try to do is like lower the results. But then what really happens is that this tree isn't an amazing model, so it has errors. And then these errors, what you can do is you can say, okay, let's try to minimize those errors. So basically, then the next tree comes, and then instead of learning the original subtractions, let's call it, between the predictions and so forth, instead of learning the original labels and trying to find predictions for them, now it's learning the differences, like that minus that. I'm like rounding a few corners here, like if there's really a coefficient and so forth. Mm-hmm. So this is like the classic XGBoost. So what happens is in each phase, what you end up doing is you're learning the mistakes of the ensemble up to date. So each time you add another tree, then the total model is the weighted sum of those trees. You have the result of the first tree plus the result of the second tree plus the result of the third tree. That's equal to the one prediction. So that's the original algorithm basically for gradient boosting. Of course there are coefficients there as well. Now what turns out is for this method, which is state of the art everywhere, even though you're using the exact same basically labels at the end, you're trying to predict the exact same features. The y is changing every time. Predictions, what you're learning, is changing every time. So part of the idea of ensemble methods is that you're trying to make these models different from each other. This comes from something which is intuitively related to Condorcet's jury theorem, where the idea is that given models that are similar accuracy but different enough, then you get to the point where you can have infinite accuracy. The idea in advance, and there are a lot of parameters if you play around with either Random Forest or XGBoost or anything similar, where these parameters are meant there just to put in noise. So the idea is if they're different enough from each other, then the combination at the end will be more accurate. So this is used a lot in catalog competitions as part of ensembling and in many different methods. Now, I think what was novel about OgBoost is we said, okay, why would I have what I'm learning, the label, why would I have that change in every time where I'm trying to create this sort of variance, but then the features would be the exact same features in every case. So it turns out features can be presented in different ways. So there are one example is you can just do something called a random projection. You take kind of within imagine within 3D graphics, you can look at the same thing from a different angle. So that's like one way to like play around with the features. The other like more is kind of like PCA. You say, okay, if I would, run, the algorithm within PCA to like make more condensed information somewhere, I could get like features that are more informative somewhere. And then I think the method which we like the most, or which is the most innovative here, is using a neural network to create like embedding layers that describe the features in a different way, which like isn't really human explainable, or at least not in every case. So each time what you're doing is you're saying, I'm taking basically the same information, but I'm presenting it in a different way. And then either if you put in these new features instead in the later trees, or if you like combine these new features with the old features, you can get like trees that are both more different from each other, and that kind of, in the case of the neural networks, is based on information that's learned from like the later stages. So like now that so this is like basically how it works. Imagine you have like 100 trees. So for like 10 trees, I just learned from the original features. Then the next 10 trees, I say, okay, now I want to learn from the original features, but also like 10 new features I'm going to extract from a neural network. Which neural network? I'll make a neural network that learns like exactly on the same label that the tree is going to learn on, and then it'll then the embedding layer will have information that like helps you get a good score on those. So it's like relevant information. And then like every 10 trees, you like change what are the features you're using to build the tree or the trees for the next 10 steps. So that's like the basic algorithm. I might have like explained it like a bit over complex, but what's really cool about it is it outperformed all the like existing ones. I'm not proud of like my code from the time. You can find it on GitHub, and I think theoretically with like more coding work here, it could potentially be like the state of the art, like better than all the existing models for tabular. In some cases, it's much slower. Like when you use the neural networks, it's much slower.
Right.
But like for PCA, it's pretty much as fast, and potentially could be like the leading state of the art today.
Cool. So my question is, if you want to create an embedding, do you need to train a neural network model first on the data?
Yeah. Okay, that's why this is like computationally expensive. The neural network method. It's even more than one. Each time you want to update the features, which is like let's say once every 5 or 10 trees, you're training a new neural network just to get the embeddings, and then you like kill the neural network and only use the embeddings.
Right. And then when you train a neural network, do you need to make sure the performance is better than a certain percentage? Because my question is, what if the data works better in a tree, but not in your network, and then the embedding you learned might not help?
If the learning of the neural network doesn't converge well, then you shouldn't use the embeddings. In general, if you're under a certain level of performance or whatever the neural network, then you should use the embeddings for anything. Realistically, when you build a decision tree with like some really bad features, they just don't appear in the tree. So I wouldn't be like that worried. But the method is that you only use it. Like there's like a clear case in which it works.
And would you say it probably works better when the data set is large enough and has a lot of features? Because if it's for kind of a simple XGBoost problem, this might be, I don't know if it would be like overfitting. I don't know if you have done in benchmarking. Kind of curious what type of data set would work better in traditional XGBoost, or was better for AlgBoost, and what works only kind of works for neural networks. Just speaking for tabular data, is there any comparison?
So here you're forcing me to like uncover something which I think is both good and not good. I didn't base my code on XGBoost, but on the classic gradient boosting from Scikit-learn. It was just easier from like a code point of view. And then it still outperformed XGBoost on a lot of these tasks. So it outperforms like by far the original code I started from. Like the classic gradient boosting, it's doing much better than. My guess is like if you would put in all the coding work, which I think would be to start from XGBoost and only then add the upgrades, where I like skipped a lot of the upgrades to do this, then you get like much better performance. I think it would potentially just outperform XGBoost in general. I'll tell you why, because even if there's something that goes like a bit wrong or it's not perfect, the new embeddings, you still have the original information. Because Like the method we found that works better is concatenating the old features or the existing features with the new features from each round or from each iteration.
Mm-hmm.
So you're not doing a lot of harm here. The
Yeah.
only harm is to the runtime, at least in the neural network method. But the
Yeah.
PCA method was not like that far behind, and that's like
Mm-hmm.
fast.
Got it. So if you train XGBoost, you can use the feature importance score. So with Ogbooks, because there's a neural network embedding, are you able to get similar model interpretability, the same as XGBoost?
My intuition is that it'll be always a bit less explainable
Mm-hmm.
than XGBoost and so forth. But I don't think August has become a like central enough algorithm for anyone to do the research work for it. And I didn't do the research work kind of myself for it. Because, what you would end up getting is explanations that have to do with features. And here, basically the features aren't even like the same thing throughout like the entire process, like the actual features being used by the tree. I
Mm-hmm.
think what you could show, like about general explainability, is you could show like from the original features things that are related to the different levels of importance. It's a bit more complex than what you can portray because there are these complex connections between connections that some of the neural networks are across the way found and used to improve accuracy, but that like all ends up coming down to like just a few numbers that you're showing.
Have you observed any change of popularity of tools? For example, what are some tools that you used to use but you feel is going to be obsolete, and what are some of your favorite tools that you start to use more in your tech stack?
Okay, so this is always a sensitive subject. I can tell you what I think is becoming more popular.
Yeah.
Uh, Things that are becoming a bit less popular, obviously, when I started off, there were things that had to do with NIME or Weka, and MATLAB was still around. And the most sensitive one I'm going to say R. I'm kidding. I know some people still use and love R, but I think Python is definitely becoming king. I know people are talking about Julia kind of in the future.
Mm-hmm.
But I think I'm an early adopter of a lot of different things, but not of programming languages. So I think it's libraries are always a large part of it. And I think definitely with like the new Python version, some things are going to be a lot faster now in terms of like what's gaining popularity now and so forth. So obviously I'm biased, like being part of the MLOps community, but it's not surprising that everything related to machine learning in production or to like maturing machine learning and tools that are helping you doing machine learning has become already a big deal, and it's going to become an even bigger deal. Like if you think about it, so originally, like I'm just thinking about like the first few people that like created a car. So imagine that like the first 30 engineers working at Ford and like working out all the diagrams and so forth. They probably imagine that afterwards it'll just be a few people manufacturing. That's like most of the work. What actually happened is like there's a few dozen engineers that did the original work, and then there were like thousands and thousands of people over factories all over the world doing this kind of production work over time. So machine learning is like similar to that, but instead of all the cars being identical, and then you're like comparing them to like the same like model of the car. So each time the model comes out different, or the data comes out different, or there's missing data, but something still has to work. So this factory that I think is gonna start to become more like a factory, and so forth, has to like endorse and be part of like incompleteness and variance and so forth. So all these tools that are related, obviously, the spaces of testing and monitoring of machine learning models are becoming a lot more important, but also the experiment management and the serving of machine learning models and feature stores and so forth. These are all things that I think were either a fiction or like very, very early adopter type things just a couple of years ago. And I think at some point we'll get to the point where you can't really live without them. Like technically you could, but you could probably build your own bicycle from like metal, but like no one does it.
Mm-hmm. Yeah, and then speaking of MLOps tools, do you have some tools you used a lot, or you do have a favorite tool?
So I think like within each of these categories, I probably have like some preferences, and definitely like there's a lot to learn from each tool and so forth. I also am like I'm always careful like not to mention like too much by name about the specific spaces because I definitely can miss some, and in some cases I could be like not up to date, and even someone watching this video in like 2 years can like be taking a recommendation when things change. I'm a huge fan of anything that enables usage of open source, and also works well with people that are working with open source, and also that gets to the point of where you have flexibility over time. So like I'm very against like vendor lock-in, because I think, even if I'm at the point where as a vendor I might have that interest, I just think that if the common practice is you get to the point where you work with kind of like the old generation of software, where you kind of make a decision and then for like 10 years, you know that you're going to work with this type of database or this type of monitoring or this type of this, and it's not built in a way where, if something changes in your like business model or something changes in the in your system architecture, that everything's slow, and that's a huge deal. So I think some technical debt you have to assume as you progress and make larger and more ambitious projects. But I think like within each of these spaces, I think there are options that are like more binding and less binding. And I am a fan of like, best of breed API first type tools and open source when possible.
Mm-hmm. Yeah. I know Deepchecks is an open source tool for data scientists to check models. Can you tell us what is the motivation for you to start Deepchecks, and maybe also tell us a little bit what is Deepchecks?
I mean, I mentioned like my own personal past, and also, my co-founder Sheila is from a very similar background. So I'll say basically, Deepchecks would solve kind of what we potentially saw as customers. Like we would have probably bought something like this if there was, because in all these different projects we were working on, I kind of mentioned that the processes for getting them into production, or kind of getting them to work in the different scenarios, was a bit different with each stakeholder, and there wasn't like yet a process, and we'd kind of let them own it, and there was something that was really missing kind of in this space. So that like the kind of superhero origin type story I would want to tell is, and then we started an open source and it became really popular, whatever. That's not what happened. That's not what happened. We said, okay, this is an amazing place to start a company. Let's build a company. Where's the strongest pain point? And then we realized the strongest pain point is machine learning monitoring, which I do think, once you have a problem with machine learning monitoring, then, it's a significant pain point. But what we realized kind of over time is, okay, we really want to be part of the workflow of the data scientists. We don't want to meet them when they're at like a mature and kind of structured area. We want to be there at all the different phases, what I would call, training, deployment, and serving. Serving, like, when you continue to answer API calls after you're already deployed. And then like, get to the point where you're part of the whole process. And we said, wouldn't it be a dream if you could be there, when people are learning this at university, or when they're building their first models, or like, a year before they're in production. We started off actually by like, we had like a POC with it, which was a UI where you would upload like your model, and you would upload data. Then you hit like this big red, this big green button. It says like, give me a report. And you'd like download a PDF report that shows you like all the problems. When I say started out, I mean started out like with the testing part, after we already had a monitoring offering. And then we showed this to some people, and they loved it. And then we got like a few different pieces of feedback, which I think were really interesting. So one of the pieces of feedback that we got was, this isn't flexible enough. Like, I would love it, but it can drive me crazy. So I don't like your threshold for determining if something's a drift or not. So I can't do it on my own. Like, that's one thing. And then what if I want to change the order and so forth? Like things that really kind of, made sense. The other piece of feedback we got is, I would never send you the data. Like, if you had it on your website, something like that, there's no chance. And then like another interesting feedback we got is, okay, if you would release something closed like this on your website, I would open source it. Like, I would create an open source version like right away. So once people said all these things together, we realized that like the only like good way to release it is to say, okay, we want it to be an open source kind of Python package. So as soon as we realized that, we had like an internal, that you already learned from me that I'm like a fan of hackathons. So our company, we're like an amazing spirit about it. We had like, a few day hackathon, stepped in the office and all. And we try to get like a demo for or like an existing, an initial version for what a Python package could look like. At the end of this kind of hackathon, we showed it to a few like senior data scientists, and then they loved it. which was amazing to me. After working in this space for like, I don't know, a year and a half, to get to something that was much more lovable in like a couple of days, said, okay, we're on to something. So then we went to the point where we said, let's see how we can make it be like the unified core for the testing and the monitoring. And from there on, it was like a clear focus for the company, saying open core, testing is open source and so forth. Everything related to like a commercial offering, meaning both monitoring, UI, some aspects that have to do with CI/CD and so forth. That's commercial, but we have enough value we can give to data scientists here while we're both getting like the love of the community, but then also the feedbacks that help us improve the checks and the tests, which can also help like the commercial offering. So this whole like architecture that came up out of this, like it sounds like, oh wow, it's such a complex structure and so nice how you kind of thought of it, put it together. But it's just like natural evolution, and we did not think of this on day one, and we probably couldn't have.
Yeah. And what is the most challenging part about building this package? Previously, you mentioned people wanted to be more flexible, and then you want to check different type of machine learning models.
For the tabular part, the part of tabular data that we have in the testing package, so I'm pretty satisfied with what we have. I think we can improve it. There are a lot of things we can do that are really better, but like I'm really proud of it as is. And then for unstructured, which is kind of a lot of our focus today, at least in testing, it's computer vision and at some point NLP. So you get a lot more value out of the package once you use it, because you usually have like no idea what's going on within like the data of the unstructured. It's not like where you can like just like look at a histogram and kind of get some idea. But it turns out there's like a lot less standardization for how people are working with. So in the testing, to get to the point where it's convenient for people working in different methods and so forth, that's like a really large challenge. And I don't think we're ever going to solve it like to the level that we solved it for tabular. But I do think that the larger value for computer vision and NLP will, to some extent, compensate for that.
Mm-hmm. And it's open source library, so how can people contribute to it?
So we have a Slack channel. So it's deepchecks.com/Slack. And then I think, once you join the Slack, just introduce yourself. If you're interested in contributing, then just, add that, and then it'll be very easy. You'll get instructions from us. But like self-serve type of like clear instructions, here are the different packages for contributors. We're going to have that later on, but I think there's a lot of interesting work that's gotten going both with computer vision and with NLP, and then connection to CI/CD and so forth. There's a lot of work to be done, and also a lot of our best ideas to this point actually came from contributors. Like you can see on our website today, there's a tool for corrupting data and then kind of seeing what Deepchecks looks like and detecting the problems in the corrupting data. The first version for that came like 100% from someone from our community. And then like there are some really cool features within the computer vision you'll see that came 100, the whole idea came from the computer vision, from the like computer vision channel within the Slack, and then we kind of improved it a bit. So there's a lot of action that's kind of ongoing, basically both with discussions with us and with like actual code contributions. And I think like over time, this is a large part of the value that you get kind of by being part of the community also as a user.
Mm-hmm. Yeah. I know it's open source. People can go check the code, but to give our listeners just a high-level summary, what's going on behind the scenes? For example, if you want to check a tabular model, what are the algorithms? What are the checks that goes into it?
So, okay, the basic concept of the package is there are checks. Each individual check checks something, and then there are suites. Okay, the reason they're called checks and not tests is because some of them do have like a binary output, like did it pass or fail, some don't. You can have multiple like conditions that can kind of pass or fail. And then you could have visualizations. So basically a check has like calculate something, and then it can display like, it could be a JSON or a table or a graph. And on top of that, then you can like run like a condition. So that's like an individual check. It's an entity which needs to be flexible to this extent to be able to run it like in the different scenarios of like both, CI/CD and just like to see in the notebook and so forth. So, and then the suite, what it does is it runs like a bunch of checks, which are usually grouped together in like a logical way. Like, let's look at the train test split. And then, so you'll get the two different data sets, and then I run over it, and then it'll run like, I don't know, like 10 checks. And then from these 10 checks, you get like an automatic report, which I think is really cool. So this automatic report, it's like bunched into like an accordion type thing where you can like click within like a Jupyter notebook or an HTML report you get. And then it shows you like what passed, what failed, what's going on. So what types of things is it checking for? So it can look for like drift, multivariate drift. It can look for things that are like different types of data integrity issues. You can also write something like, custom checks that are just part of the suites. So it's also like a framework. So just like some example, imagine you think it's not okay to have the same, you have like two columns. One of them is like city, the other is state. So you don't want to have the same city in two different states. So then you could have a check for that. And then so like we don't give that out of the box, but then you can write a check for that comes up. So like the philosophy we're aiming for is 80% of the value out of the box. And then the other 20% is possible always because it's like very kind of developer first or kind of code oriented, but you might have to work for that. Like the customizations, do require work from you, but it is possible.
Mm-hmm. Yeah. And when people get the report, is it up to them to decide how they want to fix or improve the model? Do you give any suggestions?
Yeah, so we'll give suggestions where it's possible. Usually that's like as like text within the report. From what I experienced, usually in any case, they either know what to do once they get the problem, or the problem is like not exactly where they thought it was, and then they have to investigate and like look early up in the pipeline or talk to a different stakeholder. So part of what we offer within the report, but it's not like it's not a main part of like how we see people are operating. It's like kind of auto fixing. I will mention with our monitoring offering, then there's a concept of routing. So when you get an alert, which is like, for running these tests over time kind of creates monitoring. So then when there's like a real-time alert, then you might want to say, okay, I don't even want the data scientist to see it. This can go straight to the data engineering team.
And previously, I have read some technical blog you wrote, and you wrote some also articles on the Deepchecks website, and you're a great writer. So you came from a research background. How did you learn to write engaging content?
I think learning to write is a painful process with like, I'm not talking about like, creating good PowerPoint presentations, which you can learn pretty quickly. It's a painful process that takes about 2 years, and you need someone really strict that doesn't like cut you any slack with it. So I had that when I did operations research. We had to give like very, very high standard reports, which would like be sent to like executives like all around. And the culture there was like, you'd get everything read, kind of like I mentioned about like the presentations, but also in writing. So I learned that was actually in Hebrew. And then, I'm also native English, so it like translated kind of between them. I think writing is like a really, really, really important skill, but I think you have to start early. And if you like haven't been doing like any writing yourself until like, a late stage in your career, I don't know if then I would dedicate like 2 years to do X and Y and Z. I think like in healthy development teams, a lot of times like everyone's contributing to the documentation, but I think it is okay in these areas to say, some people on the team will be like more devoted towards writing than others. And if like no one in the team is good at writing, that it could be like a significant issue to bring someone in, especially for that, because blogs are important, but also, README and docs are just as important. But anyway, just like a few quick tips I can give about blog posts. I think that at least a third of the real estate should be not text. And I think you should never have like more than a full scroll without text. So that could be either like just images or, graphs, code snippets is fine. That also kind of breaks the ice. Then like a clear structure. If it's like very long, then also like a content at the beginning, but otherwise like just clear titles where there should be a logical flow when you're reading, even like if you would just look at the titles. Like if I would skip all the text and only look at the titles, then I would want to kind of know what your main message is already. And then, and then I think the first page you see is really important, and the closing is also pretty important, and everything in the middle also important, but not as much.
Yeah, yeah. I think that's a great point because in school we learned very formal writing. You just focus on the words and you don't think about how to add some images to make it more engaging. And when it comes to technical blogs, you also don't want to overwhelm people. You want to tell the story from, for example, code examples or images. You can visualize your model performance or the data in a way that's easier for people to grasp what you're trying to say. And also sometimes people pride to use very sophisticated languages, but it might also be hard for other people to receive on the receiving end. So sometimes just use plain language to explain a difficult concept sometimes will have better effect. And you are
Couldn't agree
very good
more.
at you're very good at building communities, and you run some events, and your open source library, the downloads also grew really fast. Can you share some advice on for folks who are interested in create their own open source project, how to build a community?
Okay, so I think I would separate it as almost into two different things. Because like events we've been, hosting, we've been doing, some in the Bay Area, just started doing some in New York, Tel Aviv. We might have an event like around reInvent in a couple of weeks. So I think that's like very different there. It's important to get like other great speakers as well, have a clear agenda, be very strict about times, make sure you announce enough in advance, have a combination of good venue, but then also not be afraid to like reach out to people directly when you're getting started in a certain geographic location. And then like, all these things together, you really have to kind of think about how am I going to get those first, like, I don't know, 50 people at this event. And then if they like, assuming that the content's good and hopefully it will be, then, it'll be easier for you to find speakers and so forth for the next times. So this is all like about events. I think that's like physical communities. It's probably similar for like online events and so forth, as long as like you're trying to give like value to the community and not bring people to the to like something which is kind of more salesy and so forth, which with that, I personally, luckily have less experience. I don't think it's as fun. About like building an open source project, which I think, community is used for like the same, in the same way, but it means something very different. I think each space is pretty different. There are some major differences. I think there's like one main decision, which is that you have to make at the beginning, which is a philosophy decision. There are two options, basically, I'd say. One of the options is to say, community knows how to receive half-baked code and release everything whenever it's ready. I'll announce it when it's ready, like initially when it's ready, kind of. And the people that use it has problems, and then it'll, they'll understand because they're not paying for it. That's one philosophy. So the other philosophy is saying, okay, an open source release, it's like a product release. People aren't going to give you another chance in the next few months, or at least some of the people. And for my intuition, the early adopters, the ones that are going to try it first, they're like the loudest people. So if they try your project and don't try it again for 4 months, it's almost like delaying your whole launch by 4 months, and it could be 8 months. So the other philosophy is you say, no, I'm only going to release the open source once I have like very clear understanding that it's going to be, pretty popular. So we went with the second approach. It's not the only valid way to go. There are definitely large advantages, especially in like feedback gathering about like releasing it as soon as possible. But then the way we did it is we had like interviews, like user interviews with like a growing number of people. And then we would say, only when we get to like most people saying, I would use the open source and I would refer it to a friend, only then we're going to release. And we stuck to that plan. I think that's what made it so popular. And yeah, we got to, like within a few weeks, like 1,000 stars.
Mm-hmm. Yeah. And you're building also enterprise version of Deepchecks. What are the features you're going to add for the enterprise product?
So the open source product is, really proud of it. And I think it's great, but I don't think it's really built for an organization. So like it doesn't deal with production that well. Like you can use it for production, but you'd have to pretty much build your own stack. It's not very UI focused. Managing within it isn't as easy. The integrations, you basically have to create your own integrations to the different types of databases and so forth. And then, it always is a possibility. We still anticipate more organizations using the open source than buying the commercial edition, because it's always the way open source works. And a lot of great organizations have great developers, and in some cases the budget isn't similar. Like if they think it's cheaper to buy Deepchecks than to hire someone to work on it, that's not always the equation, because sometimes they already hired someone. In some cases, even if they would hire less people, and they get less budget for the next year. So it's really not intuitive. I think it's just a better experience. So it's I think it's really important for teams that are both expanding their usage, either working with more data, more models and so forth, and they want to be able to scale well, more use cases that are going to production. If you have significant problems either in the way you're sampling, or in the sampling method might be complex, or it could just be challenging to do it at scale. And then both cases of very large data, or data which is sparse in the areas that you need, I think are areas where it would make sense to make an investment. And then where there are other different teams that need to talk to each other, I think there are a few different use cases in which it would make sense, not only to use the open source. And then I also think that teams that just decide to use the open source and to build around it, I could definitely understand that. And there are some advantages to it. Something it is worth mentioning, we don't have this now, but we'll have this in the future, is the ability to pay via cloud budget. So when it's setting it up as a commercial engagement with Deepchecks, that's one thing. But then at some point, we're working on collaborations with the different cloud providers to get to the point where you could have existing cloud budget that's allocated towards this, and we have an agreement with the cloud providers, and that makes it less of a large decision.
So what are you excited about your life and career right now?
Sometimes I, like to joke that I transitioned from machine learning to AI. I do miss kind of touching the hands-on code, and definitely being more within the really, really hands-on discussions. But at Deepchecks, both I think the combination of getting both getting the experience as founder and CEO, I'm learning a lot, and the whole area of business world, marketing and sales, and the connection between the product and then these different fields, and managing people, all these different disciplines. It's all new to me, and I'm getting to do that while I'm still pretty close to the technical, because I still get to speak with a lot of hands-on people and see what they're doing, and in some cases write some pretty basic demos, and then definitely sit with our algo team and kind of while they're doing the brainstorming and architecture design. So that's what I'm really excited about what we're doing now. I think that going forward, it's definitely a combination. What I'm excited about continuing to work with open source in some ways, and also continuing to be related in some ways to machine learning. It doesn't have to be always combined as strongly as now, but I found a very strong passion for both of them.
Yeah. Well, thank you so much, Philip, for coming to the Data Scientist Show, sharing your career journey and Deepchecks. So for folks who are interested to learn more about you and Deepchecks, where can they find you online?
LinkedIn is the best.
Cool. I will add it to the show notes.